On the off chance that you put bug juice where the sun is, it would reach out to the orbit of Jupiter, a beast absolutely massive and on the verge of exploding. It is among the most unmistakable sources of radio energy in the entire universe, emitting more energy than a billion suns. Creepy Crawly Squeeze, or bug juice, is a red supergiant star. If you placed it where the sun is, it would extend to Jupiter's orbit. It is enormous, unpredictable, and also likely to explode. When we think of stars, we usually picture tiny, twinkling lights in the night sky. This is how they appear to us from Earth, but in reality, stars are something entirely different. One of the most well-known stars, Betelgeuse, is significantly larger than our sun. For years, this star has puzzled scientists. However, something even more alarming has been happening with Betelgeuse, causing astronomers and experts to be incredibly concerned. Join us in this discussion as we explore the latest news about Betelgeuse, its potential destruction as predicted by the James Webb Space Telescope, and what this new development means for our universe and life on Earth. As physicist Michio Kaku explains, Betelgeuse is a colossal wonder, a massive star that has fascinated astronomers for centuries. A Greek astronomer named Antonius was the first to discover it. This star is so enormous that it can be seen from Earth with the naked eye, especially during winter. If you're into astronomy, you've probably seen or heard of it. The reddish-orange star marks the upper left shoulder of the Orion constellation. Betelgeuse is an ancient star, possibly one of the brightest in the night sky. However, its brightness does not remain constant. Instead, it fluctuates. This variability is one of its unique properties, but it is not the only one. Exploring Betelgeuse's unique properties. Most stars in the night sky are incredibly far from Earth. The closest star, Proxima Centauri, is 4.2 light-years away. To grasp this distance, imagine traveling at the speed of light, 186,000 miles per second, for an entire year. That distance is roughly 1 light-year. When we say the closest star is 4.2 light-years away, we mean it is billions of miles from Earth. Now, consider that some stars are much farther away. Betelgeuse is one of them. It is located approximately 600 light-years from Earth. Even if we could travel at the speed of light, it would take 600 years to reach it. Our fastest space rockets are nowhere near capable of such a journey, yet Betelgeuse still shines brightly in our sky. How can Betelgeuse be so bright despite its distance? The answer lies in its immense size and luminosity. Betelgeuse is several hundred times larger than our Sun, with an estimated radius around 800 times that of the Sun. Unlike other distant stars, which appear as tiny points of light, Betelgeuse appears as a visible disk in space when viewed through modern telescopes. In terms of mass, Betelgeuse weighs approximately 12 to 19 solar masses. A solar mass is the standard unit astronomers use to measure the mass of celestial objects, equivalent to about 2 times 10 superscript 3 kg. Scientists cannot determine Betelgeuse's exact mass because it lacks orbiting planetary bodies for comparison, and direct measurement is impossible from Earth. However, it is at least several times more massive than our Sun. Betelgeuse's brightness fluctuates between magnitudes +0 and +1.6. In simpler terms, it is typically much more luminous than our Sun, earning it the nickname Red Giant. However, its brightness is not constant. It changes due to the star's pulsations. As Betelgeuse expands, it becomes brighter. As it contracts, it dims. This cycle can last from 10 to 100 days or even longer. A unique characteristic of Betelgeuse is its surface, which is covered in dark magnetic spots. The magnetic field on Betelgeuse is much stronger than that of a typical star. However, these powerful magnetic spots interfere with the flow of hot gas to the star's outer surface, causing cooler regions. This explains why Betelgeuse is cooler than the Sun despite its size and brightness. The Sun also has dark magnetic spots, but Betelgeuse's are significantly larger and more numerous. To give you an idea, Betelgeuse's spots can be twice the size of Earth. Additionally, Betelgeuse boasts a magnetic field 200 times stronger than the Sun's. This field causes the gases on the star's outer layers to appear in swirling patterns when observed through telescopes. Betelgeuse has a surface temperature of approximately 3,500 Kelvin, which contributes to its weak energy radiation and characteristic red color. However, Betelgeuse was not always red. About 2,000 years ago, it was yellowish, similar to our Sun. Over time, it transitioned to orange-red, and around 1,000 years ago, it slowly evolved into the red star we see today. This color change has led scientists to believe the star is aging rapidly. Betelgeuse emits about 100,000 times more energy than the Sun. If it were closer, it would outshine everything in the sky. The fact that Betelgeuse, despite being 600 light-years away, is visible to the naked eye at night is astonishing. Our Sun is only 8.3 light-minutes away from Earth, making it incredibly powerful in our sky. If Betelgeuse were even slightly closer, we would see it during the daytime as well. However, if it were to replace the Sun, it would engulf Earth and the four inner planets due to its immense size. Even if it were only the size of the Sun, it would still emit much more radiation. Betelgeuse, also known as bug juice or bug dew, a misinterpretation, is one of the most massive stars in the universe. Its fate is uncertain, but astronomers continue to monitor it closely. Heavenly body Orion is around 600 light-years from Earth. Its tremendous size is one of its most striking features. It is many times larger than our Sun in terms of radius and could easily envelop the orbit of Jupiter if placed at the center of our solar system. This incredible size allows Betelgeuse to appear as a disk rather than a point of light when viewed through powerful telescopes. Unlike most other stars, despite its size, Betelgeuse is not the most massive star. Its mass ranges from around 12 to 20 times that of the Sun. This variation in mass estimates is due to the difficulty in precisely measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. Still, even at its lower estimated mass, Betelgeuse remains a colossal celestial body. The brightness of Betelgeuse is another key characteristic. It fluctuates constantly over time, with its magnitude ranging from 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be up to 100,000 times more luminous than our Sun. This variation is due to its pulsations, periodic expansions and contractions caused by internal processes within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for years, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, measuring around 3,500 Kelvin. This gives it a distinctive red color, typical of red supergiant stars nearing the end of their life cycles. Like other red supergiants, Betelgeuse is in the late stages of stellar evolution. It has exhausted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere exhibits complex physical phenomena, including dark magnetic spots on its surface where the magnetic field is stronger than surrounding areas. These spots prevent heat convection, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains an extremely energetic star, but it will eventually meet its end in a spectacular supernova. The fate of Betelgeuse. Betelgeuse, a massive star approaching the end of its life, has a dramatic fate ahead. When it runs out of fuel, it will undergo extreme fusion, forming heavier elements like helium and carbon. This will cause the star to expand even further, potentially becoming one of the largest stars in the night sky before it dies in a massive explosion. A supernova is a catastrophic event that marks the death of a massive star. The impact of such an explosion is powerful enough to momentarily outshine an entire galaxy. This phenomenon could send shockwaves through space, and it is possible that Betelgeuse will experience such a fate relatively soon in cosmic terms. While not imminent, scientists are closely monitoring it to learn more about the life cycles of stars and the evolution of the universe. As Betelgeuse approaches the end of its stellar life, astronomers are paying close attention to its behavior. The star is expected to eventually go supernova, an explosive event that will eject its outer layers into space, leaving behind a dense core. Depending on its final mass, This core could become either a neutron star or collapse further into a black hole. A supernova is a critical event in a star's life cycle, marking its final stages of evolution. Betelgeuse's potential supernova could be visible from Earth without a telescope due to its immense brightness and relative proximity. This explosion will release vast amounts of energy, creating heavy elements like iron and nickel, which are essential for the formation of planets and other celestial bodies. These elements will be scattered across the universe, enriching the interstellar medium and contributing to the formation of future generations of stars and planets. Interestingly, scientists have detected unusual fluctuations in Betelgeuse's brightness in recent years, leading to speculation that it might be on the verge of a supernova. However, predicting exactly when it will explode remains difficult. Some experts suggest that Betelgeuse could go supernova within the next 100,000 years. A short time span in the life of the universe, but still too uncertain to pinpoint exactly. The James Webb Space Telescope, JWST, has provided new insights into the star's behavior. Its infrared capabilities allow scientists to study Betelgeuse's outer layers and magnetic fields in great detail. JWST's findings have confirmed the star's ongoing changes, including its irregular brightness variations and potential instability. These observations provide valuable information about the processes leading up to a star's death, enhancing our understanding of stellar evolution. The legacy of Betelgeuse. The death of Betelgeuse will have far-reaching consequences for the universe. The supernova shockwave could potentially trigger the formation of new stars in the surrounding region, continuing the cycle of stellar birth and death. Moreover, the elements produced in the explosion will spread throughout space, serving as the building blocks of new worlds. In the grand scheme of cosmic evolution, the demise of Betelgeuse will not only mark the end of one of the most massive stars we can observe but also pave the way for the next generation of celestial objects. While we may not be around to witness its final moments, the study of Betelgeuse provides valuable insights into the life cycles of stars and the dynamic nature of the universe. The research conducted on this star helps astronomers better understand the processes governing stellar birth, life, and death. It offers a glimpse into the fate of other stars with similar characteristics. In the future, scientists hope to continue studying Betelgeuse with advanced technologies and space observatories. The data collected from this star will continue to shape our understanding of astronomy, helping us unlock the mysteries of how stars evolve and how their explosive deaths impact the universe. In conclusion, Betelgeuse, as a massive and dynamic star, is a significant piece of the cosmic puzzle, and its eventual destruction will be one of the most fascinating events in our galaxy's history. While its death is inevitable, it's important to remember that the universe is constantly changing and evolving. New stars are being born all the time, and the energy released by supernovae like Betelgeuse's will ensure that the cycle of life and death in the cosmos continues. The legacy of Betelgeuse will live on, not only in the elements it produces but also in the knowledge it provides to generations of astronomers and stargazers. By studying stars like Betelgeuse, we can continue to unravel the secrets of our universe, gaining a deeper understanding of the forces at work and our place within the cosmos. As we learn from these stellar giants, we are reminded of the vastness and complexity of space and the captivating processes that shape the universe we call home.